Okay, good morning, students. Am I audible and screen is visible? Hello?
Yes, sir.
Okay. Okay, we'll start today's class. All right. In the previous class, we have discussed about the multiplexer, and I hope all of you understood what exactly the multiplexer is and how a multiplexer can be designed or implemented, and how higher order multiplexers can be obtained from lower order multiplexer, and how a multiplexer can be used to implement any Boolean expression. Right. Now, in this class, we are going to discuss about the other data processing circuits like decoder, encoder, etc. Right. Before we discuss about decoder and encoder, I want to give you a brief idea about demultiplexer. Actually, we are not going to study demultiplexer here. Modification of demultiplexer we are going to study, and that itself is decoder. We have to start discussing decoder, but before we discuss about decoder, I want to give you a brief about what is demultiplexer. Though we are not going to discuss in detail about demultiplexer here in your syllabus. What is multiplexer? Multiplexer is a combinational logic circuit which has many inputs and single output, and one among the many inputs will be passed to the output depending on the select line or the control lines. Exactly opposite to that function is performed by a combinational circuit called demultiplexer. So what is demultiplexer? It is basically one to many, opposite of many to one. Multiplexer was many to one, so demultiplexer is one to many, which you can see from this particular diagram here. Here you can have one input and multiple outputs, and again there are different control inputs. So what this particular circuit does, this single input will be passed to one of the many outputs depending on the select line. We have a single input, but that where it should be passed to which output, that will be decided by the control circuit. That is what is called as demultiplexer. For example, I'll show you one demultiplexer here. What demultiplexer you can see here? It is called as 1:4 demultiplexer. Means what? It is having single input and 4 outputs. But where this single input D is passed, which output it is passed, that depends upon the two select lines, which we have shown here as S0, S1. So if S0 and S1 is 0, 0, what happens? The input D is passed to the output Y0, and the other three outputs will be 0. That is what is important. You can see from this truth table. If 0, 0, D will be given to Y0, others will be 0. Similarly, if it is 0, 1, D will be given to Y1 and others 0. And if it is 1, 1, D comes to Y3 and the remaining three outputs are 0. Such circuit is called as demultiplexer. Right? So why I have told this demultiplexer is because, as I said, we are going to discuss about decoder now. So what is this decoder? We are going to discuss in detail. So just you have to remember, demultiplexer is opposite of multiplexer, wherein there is a single input and many output, and this single input is passed to one of the many inputs, many outputs depending on the control lines or the select lines. Now, what is a decoder? This is what actually we are going to study, right? I hope all of you understood what is demultiplexer, though it is not there in your syllabus. To understand decoder, you should know the little bit knowledge of demultiplexer. So I have covered just in 1 or 2 slides. Is that clear? All of you understood what is demultiplexer? Yes?
Yes, sir.
Yes, sir.
So we'll go ahead with the decoder then. So first line itself, all of you can read there. What I have written? A decoder is what? It is
similar to demultiplexer.
Similar to
demultiplexer, but there is one exception. With one exception, what is that?
No data output.
There is no data input. So what exactly you mean by this particular sentence? As I said, it is similar to demultiplexer, but there is no data input, and that's what you can see it in the block diagram. I hope the block diagram is visible there. What I have shown in the block diagram. Yes. What is shown there in the block diagram? You can check. Yes. This is the block diagram of what? A decoder. So what it shows is there are n data inputs and 2 to the power n possible outputs, but there is no what you can say the data input which is there in the demultiplex. Again, don't get confused. Here I am calling data inputs and here I have written there is no data input, right? If you compare this with the multiplexer, that single data input which is there, that is missing here, and the select lines which are present in the decoder demultiplexer, that itself act as a data inputs here. I hope the difference is clear. The select lines of the multiplexer acts like a data inputs, and we have 2 to the power n possible outputs. In short, what we can say is decoder is a combinational logic circuit which can have n inputs and 2 to the power n outputs, in simple words, right? That's why normally this decoder is called as binary to decimal decoder, right? So if you give n bit inputs, you are going to get the 2 to the power n possible outputs, right? So depending on the number of input lines, the inputs of a binary code can be either 2-bit, 3-bit, 4-bit, right? In general, there can be n inputs and 2 to the power n outputs. Such a combinational logic circuit is called as a decoder, right? So the most commonly used practical binary decoders are 2 to 4 decoder, 3 to 8 decoder, 4 to 16. It is obvious. When I take 2 inputs, how many outputs I am going to get? 2 to the power 2 equal to 4. If I take 3 inputs, outputs will be 2 to the power 3 equal to 8. If you take 4 inputs, output will be 2 to the power 4 equal to 16. So we have 2 to the power decoder, or 3 to 8 decoder, or 4 to 16 decoder. So sometimes the 2 to 4 decoder is also called as 1 of 4 decoder. What is the meaning of 1 of 4? Actually, there are 4 outputs. Based on the 2 inputs, 1 of the 4 will be selected. It is. That's why sometimes these decoders are also called as 1 of 4 decoder, or 1 of 8 decoder, or 1 of 16 decoder. That means at any given time, only one output will be active depending on the inputs what we have given. So there will be n inputs and 2 to the power n outputs present in the decoder, right? So we'll see now how to design 2 to 4 binary decoder. So what exactly you mean by 2 to 4 binary decoder? When I say 2 to 4 binary decoder, you will have how many inputs now? Yes?
2 inputs.
2 input, and you can have
4 outputs.
4 outputs, right? So what is the relationship between the input and output? That can be explained by the function table of the decoder. The same diagram which I have drawn there is shown. So 2 to 4 decoder I have taken, where there are 2 inputs A and B and 4 outputs Y0, Y1, Y2 and Y3, right? Can anybody tell me what is the relationship between the input and output here? I have shown 2 inputs A, B and the 4 outputs Y0, Y1, Y2, Y3. How we should draw the truth table or the function table of this decoder? Yes?
Depending on the value of
tell
A
me the
and B,
relationship between
output will
output
be
and
decided.
input? Yes?
Depending on the value of A and B, output will be decided.
Depending on the value of, not able to hear, I'll just increase the bit volume. Yeah. Depending on what?
Value of A and B.
Depending on the value of A and B,
Output
what
will
happens?
be decided. Output
What?
will be decided. Output will be decided, sir.
Output,
Anyone
that's
will
what.
be
Now A and B, there are 2 inputs. So how many values A and B can take?
4 values.
What are the 4 values?
0, 0, 0, 1, 1, 0, 1, 1.
1, 1. So if A and B are 0, 0, what output you are going to get now?
For Y0, we will get
Y0 will be high and Y1, Y2, Y3 will be
low.
It is a decoder. 0, 0 means Y0 will be decoded. That is Y0 will be high. That's why it is called as 1 of the 4 decoder. Means out of 4 outputs, 1 will be active at any given time depending on the inputs. Normally in demultiplexer, what happens? What input you have given, that will come into the one of the outputs. But here there is no input. Depending on these select lines or the input lines what we are having, one of the multiple outputs will be made high. So if A and B are 1, 1, what output you are going to get?
Y3.
Y3 will be what?
High.
High.
And
Others
what
will
about the
be low.
remaining? You should
Low.
not say Y3 only. You have to tell the entire output, 4-bit output.
Yes.
What
Y3 will
output you are
be
going to get?
Y3 will be high, and other Y0, Y1, Y2 will be low.
That means you are going to get the output as 0001 or 1000 if you write from MSB to LSB. That's what is shown here. You can see that. Right? I hope this function table is clear. When the inputs A and B are 00, you can see there Y0 is high, remaining 3 are low. Similarly for 01, Y1 is high, the other 3 are low, and similarly for 10 and 11. I hope it is clear, decoder, all of you understanding. Now you have to draw the logic diagram for this. You can see the logic diagram, how it is drawn, right? A and B are shown. This is A, right? Again, I need to take, sorry. Yes, this is input A, and by putting a NOT gate, you will get A bar. This is B and B bar. So what inputs you have to give it to the first AND gate? A bar and
A bar,
B
B
bar.
bar.
A bar, B bar, if both are like A and B are 00, you will get Y0 equal to I, all other will be low. So there is no separate OR gate. Normally you will do the mistake. You will take the output of these, again you put it to what? OR gate. Right? Here you should not do that because you have 4 different outputs, that is Y0, Y1, Y2 and Y3. I hope designing is clear of my decoder. All of you understood?
Yes, sir.
Okay. Now we'll go ahead. 3 to 8 binary decoder. What exactly 3 to 8 binary decoder will consist of? Can anybody tell me?
3 data inputs and 8 outputs.
8 outputs. Then what will be the truth table consist of?
A, B, C,
Okay.
and D0 to D7.
D0 to D7 or Y0 to Y7 or F0 to F7, Z0 to Z, whatever you want, you can write. Yes. Inputs
Yes.
also you can write anything. There is no rule that input should be shown only by A and B. Right? You can write anything. Here I have shown the 3 inputs as what? A, B, C, and the output as what? Y0 to Y7. Then the truth table. What you can see from the truth table, when the first input combination, when these 3 are 000, which one is high?
Y0 is high.
Y0 is high, all other are
Low.
Low.
0. Similarly, if you take 101, if the input is 101, which is high? Y5. That's what I said, no. Binary to decimal decoder. 000 means 0. 101 is how much? If you take binary 101, in decimal it is how much?
6.
101 is 6. Huh?
5, sir.
Yes. 4 plus 1, how much, madam?
5, 5.
5. Right? So that's what? Fifth Y5 will be high. Similarly, 111 means how much?
7.
111 means 7. So in that case, which one will be high?
Y7.
Y7.
Y7 will be high. People, please try to join on time. It will disturb everyone. Then I have shown here the logic diagram for the same. This is the logic diagram. You can see how it has been implemented. I hope it is clear, all of you. Getting that diagram? Like how we have done 1 to 4 decoder, like that it is 3 to 4 decoder. Is it fine? All
Yes.
of you understood it? Yes, good. That is the designing of it is very simple actually, designing of the decoder, right? So a decoder generates all the minterms of the 3 input variable and only one will be active at any given time, right? So here 4 to 10 line decoder is shown, right? These are like a special decoder. Standard decoders, as I said, will have n inputs and 2 to the power n outputs. But here how many inputs are there now? How many inputs I have shown here? 4 inputs. So normally 4 inputs means we should have 16 output. But we have taken here what, only 10 outputs. So this is called as special decoder, right? In fact, it is called as what you can call it as a binary to BCD decoder. That means if I give input as 000, I'll get the output as 0. Similarly, if I give the input as 1001, what output I will be getting? If you give ABCD as 1001, that is the last input you can give. So what output you will be getting in that case? You will be getting it as what? 9. So this is called as, basically it is called as binary to decimal decoder or binary to BCD decoder. Because decimal number system, how many you are having? Digits 0 to 9. So such decoders are called as special decoders. Is that clear? The same. Then you may ask here why NAND gate is used. When NAND gate is used, it is called as active low decoder. Is that clear? If you use AND gate, whatever decoder you get is called as active high decoder. And when you use NAND gate, it is called as active low decoder. So suppose if you have here in this case also, in this also suppose instead of active high, right, if the outputs are active low outputs normally will be shown like this. You will put a bubble here, right? If I show the bubble, this becomes active low decoder. Then can anybody tell me what changes you need to do here in the truth table? If you add a bubble at the output, it is called as active low decoder. So for active low decoder, what changes you should do? This is called as active low decoder. So what changes you should do in the truth table? Yes? What changes you need to do here? Active low. When A and B are 0, 0, Y naught is active. So Y naught is active means what? You should get Y naught as what?
0.
0, and all others should be
1. High.
Whichever is active low, that should be low. So Y naught should be 0, remaining should be 1. Similarly here, Y1 should be 0, remaining should be what? 1. Right? I hope the difference is clear between active low and active high. So if it is the active low decoder, you will get the outputs like this. This will become 1, this becomes 1, this becomes 0, this becomes 1, then again this is 1, 1, 1, and this becomes 0. Right? Then what change you need to do in the circuit diagram? What change you need to do in the circuit diagram if it is active low decoder? You need to make this AND as NAND. You should make this AND as NAND, and here also you are going to get the output as what? Complemented. I hope the difference between active low and active high decoder is clear. All of you understood?
Yes. Yes.
Yeah. Any difficulty, doubt? If you have, you can stop me and you can ask. Any doubt, Sahil?
No doubt, sir.
Okay. So all of you understood designing of decoder? 1 to 4 decoder or 3 to 8 decoder, like that. 4 to 16 decoder also easily you can design. But instead of going for 4 to 16, I have given here 4 to 10 line decoder, which is called as a special decoder, right? And this is what is shown actually. 4 to 10 line means we have to actually, if you see 4, what happens is we will get only till this point, right? But with 4 we are going to get 16 combination. So what about these remaining 16 combinations, 6 combinations? Only 10 we are using. We are not using the last 6 combinations, right? So it is called a special decoder. In that case, if any of these combination arises, all the outputs are inactive. Which kind of decoder I have shown here? Whether it is active high or active low?
Active low.
Active low. That's what you can see. When ABCD are 0, 0, 0, which is active? This is active. Here 0 is considered as active, 1 is not considered as active. So all are inactive, only this is active. You can see, depending on from 0, 0, 0 till 1, 0, 0, 1, 1 will be active at any given time, like this. Only 1 is active at any given time, all are inactive, all others are inactive, and for the last 6 combinations, what happens? What you can observe for this last 6 combinations? All are what?
Inactive.
Inactive. That means these 6 combinations should not be considered. No output you are going to get for the last 16 because we are not using 4 to 16 decoder. We are using which decoder? 4 to 10 decoder, which is a special decoder, as I said. Normally, if you have 4 inputs, means compulsory you should get 16 different outputs, but we are not using all 16 outputs here. We are using only first 10. Hence, this is a special decoder, like as I said, the binary to BCD decoder you can call, or binary to decimal decoder, right? So this decoder has inverted outputs. That's why it is called as active low. When binary coded decimal digit is used as an input to this decoder, one of the output lines will go low to indicate which of the 10 decimal digit is present, right? That is designing of the decoder. Then in general, how the outputs can be represented is shown here, like how we have represented in case of multiplexer. In general, the output of a decoder can be represented by this. What is this? Yi equal to Mi. What is small mi? What is small mi here? Small m means min term. Output will be equal to the min term. If it is 0, 0 for 2 inputs, what is the min term you are going to get? First min term, A bar, B bar, right? 0, 0. So that itself is the output of the decoder. Yi equal to Mi. That means Y0 equal to A bar, B bar, Y1 equal to A bar, B, Y2 equal to A, B bar, and Y3 equal to A, B, like that. That is for the non-inverted outputs. If you have the inverted outputs, what you will get for the inverted outputs, you can see Yi will be what? Complement of Mi. Like you have to take the complement and you can write the general output equation for the decoder, right? So various applications of decoders are mentioned here. Just you can go through this slide. Decoders are greatly used in applications where the particular output or a group of outputs to be activated only on the occurrence of a specific combination of input level. So examples of the various decoders are binary to decimal decoder. Then we have the address decoders. Normally in microprocessors and all, where you want to access the memory location, these decoders plays a very important role. I hope you might have studied already in your computer organization subject. If you want to access a particular memory, the memory address register will be there. How is that memory address register, MAR, gets the address, or how it sends the address on the address bus? There is a separate data bus and address bus will be there, and the address has to be sent on the address bus to access a particular memory location, and then that memory location can fetch the data from that particular location and it can be brought onto the data bus. So there will be normally 3 different types of buses present in a microprocessor based system, and those 3 buses are called as, can anybody tell me what are the 3 buses? In fact 2 I have told already now, but actually there will be 3 kinds of buses which you might have studied in your computer organization subject. Can anybody tell me? Omkar? Yes? There are 3 different types of buses available actually. What are those 3 different types of buses?
First is address line bus.
Address bus.
Second is control line bus.
Okay.
Third is
Data bus.
Exactly, you are right. There are normally 3 types of buses present: address bus, data bus, and control bus. What is address bus? All address lines are put together and they are called as a bus, address bus. Right? Data bus means what? All data lines are put together and you will get, it is like group of wires you can call, which transmits the address, that is called as address bus. Group of wires that carries the data, that is called as data bus. And group of wires which sends the control signals is called as a control bus. So all these buses, like they have to decode a particular address. So there the decoder plays a very important role. We use address decoder or we use instruction decoder. This you might have already studied. Instruction register present in your structure, architecture. What it does? Can anybody tell me? In ALU or CPU, you can find one instruction register, right? That does the decoding work. Instruction decoder. What is instruction decoder? Yes? Yes, Shreya, can you tell me what is instruction decoder?
Yes, sir.
what is instruction decoder? You have studied, no, instruction register, memory address register, all these different registers and all you have studied, right? So
Yes,
there
sir.
you might have heard about instruction decoder also. What exactly instruction decoder does? Yes?
So no idea exactly.
Instruction decoder means what? Normally,
It-
say to your CPU or ALU, you give the instruction like add A comma B. What add A comma B does? Suppose if I write ADD space A comma B, this is the instruction given to your ALU or CPU. What it
Yes, sir.
should do?
It should add.
Why it should add only? How it will come to know that he has to add by upon receiving that particular instruction? How do you say that? If I give you add A comma B, A and B are two registers, you assume the content of these two registers should be added and the result will be stored in register A. That's what it should do, right?
Yes,
Similarly,
sir.
if I ask you to tell me what is say SUB A comma B, what it should do? If there is an instruction called SUB A comma B, yes,
Subtract A
It should
comma B. It has to read the
subtract A and B.
subtract B from A and store the result in A. That's what. So how you are telling this? If I give you add A comma B, you are telling it should add the content of A and B and store result in A. And when I give you SUB A comma B, you are telling it should subtract the content of B from A and store the result in A. How you are telling these answers, different answers for the different instructions? Because
because of decoder.
you know what that instruction does, you are decoding that instruction. So that instruction decoder will do this job what you have done now. I have given you two different instructions, but the instruction decoder can have thousands of instructions it will be facing, and it will come to know what is the meaning of that particular instruction, and accordingly it behaves, or accordingly it executes that particular instruction. So there these decoders are very important, right?
Yes,
And
sir.
as this also already I have told you, if the decoder input it should be active high, then you can use what is called as an AND gate. And if you want to have inverted output, then you have to go for the NAND gate. And normally these decoder, very important application of decoder is, decoders are used to implement n variable functions. Like in the previous class we have seen how we can implement a Boolean function using mux, using a normal mux, or using lower order mux also we have seen how it can be done. Exactly in the same way, these decoders are also used to what? Implement variable functions. N variable functions can be implemented using what? This decoder. And that is the important part which we are going to study now. So before we go to that, are there any difficulties? You understood what I have explained to you people now in the decoder? All of you understood what is decoder or no?
Yes, sir.
Yes, sir.
So now what we'll do is we'll take one simple example and we'll see how we can implement a decoder, implement different functions using these decoders. Fine? Is that clear? If you understood the what exactly the decoder is, now we'll see how we can implement the different functions using decoders. Yes. So all of you can take down this example. One simple example I'll take before we go to the other different examples. All of you can take down this particular example. I hope the screen is visible for you people. What is written there? Yes? Is it visible?
Yes, sir.
What I have written there?
Implement following functions using 3:8 decoder.
Implement following functions using 3:8 decoder. Right. Now you can just take down this question and we'll see how we can implement it. Right. We will try to implement that using the decoder. Right. I hope board is visible for you people. Is board visible or no? Is it properly visible?
Yes, sir.
Okay. We'll solve this example now using decoder. Yes. What are the functions given to you? First function given is what? F1 of A comma B comma C equal to sigma m. What is given?
035.
0, 3, 5. F2 of A comma B comma C equal to sigma m
1,4.
1 comma 4 and F3 of A comma B comma C equal to sigma m
2457.
2, 4, 5, 7. What is the question asked? They have asked you to implement these functions using what? You have to implement these functions using what? 3 to 8 decoder. Now how we can do that using 3 to 8 decoder, how it can be implemented. That's what we need to study. So here, how many inputs are there in this given expression? Yes. How many inputs are there?
3.
3 inputs ABC.
3 inputs are there. Hello? Okay, sorry. Is the board visible?
No, sir.
Board is not visible. What happened to that? Okay, just a minute. Something. Is it visible now?
No, sir. No, sir.
No, sir.
No. Oh, sorry. Yeah, now I think it is visible.
Yes, sir.
Yeah. So now how many outputs are there? How many inputs are here?
3 inputs.
There are 3 inputs. Okay, board visible or no?
Yes, sir, visible.
Yes, sir, visible.
Parity is there?
Yes, sir.
Sure. Right. Now there are 3 inputs. Right. And how many outputs we are having? How many
8
functions
outputs.
we are having? How many functions we are having?
3
Three
functions.
functions, F1, F2 and F3. So this is 3 input, every function is of 3 variables and there are 3 functions. Such 3 functions we need to implement using what? 3 to 8 decoder. So which decoder to use, that depends upon how many input variables you are having. How many input variables you are having?
3 input variables.
3. So you should go for which decoder? You should go for what? 3:8
Decoder.
decoder. So 3:8 decoder will have how many inputs?
3 inputs.
And how many outputs?
8 outputs.
1, 2, 3, 4, 5, 6, 7, 8. Fine. Now the 3 inputs we have to name A, B, and C. And we have the outputs like this is 0, 1, 2, 3, 4, 5, 6, 7. Hope it is clear. 3 to 8 decoder. Now, how any function can be implemented using the decoder? Whenever you are implementing any function using decoder, that's what I have shown in the previous slide. If you remember, a multi-output function can be implemented by using a decoder and a OR gate, or if you want the inverted active low output, a decoder and the NAND gate. If you have active high decoder, you have to use a multi-input OR gate to implement that function. And if you have active low output, then you have to use the NAND gate to implement that particular function. Right. So how do we implement this now? First function. You take the first function now. What is the output of the first function? F1 of A, B, C equal to 0, 3, 5. That means when the inputs A, B, C takes the values in such a way that corresponding to the decimal value 0, 3, 5, the output should be high. So what you should do now? Take 0. You should take 0, then 3 and 5. So one of these 3 is high, F1 should be high. So what gate I have to use here? Any one of these is high, the output F1 should be high. So which gate I should use?
And gate.
OR gate.
Which gate? Any one. You need to use what? OR gate. And the function F1. Is that clear? Similarly, can you tell me F2 how I should implement? One function I have implemented. This is very easy and simple way to implement using a decoder and a OR gate. Now how I should do the next one? Next what I should do?
1 and
I
4.
should take here itself. Multi-output functions you can implement. Next you need to take 1 and 4. Use one more what?
OR gate.
OR gate. And write F2. Then 2, 4, 5, 7. 2, 4, 5, 7. You take again. 2, 4, 5, 7. This should be given to one more 4 input OR gate and you write it as F3. So this is how we can implement any Boolean equation or any multiple input multifunctions can be implemented using 3 to 8 decoder, any decoder and the OR gate. I hope it is clear. All of you understood this? This
Yes.
example clear or no? All of you understood this or no? How to implement function using decoder? Okay, so can you do one example now? Yes,
Yes,
all
sir.
of you should try. Implement full adder using decoder and OR gate. Implement full adder using decoder and OR gate. All of you please try that. Yes, do it all of you. Yeah, what I told, design full adder using decoder and OR gate, using 3 to 8 decoder and the OR gate. How we should do it? Design full adder using 3 to 8 decoder and the OR gate. Anybody did it? Yes? Have you done it? Tell at least yes or no. If you have not done, say no. If anybody has tried it, till what point you have tried, you tell the further part. If you are not getting, I tell you. Right? So how to implement a full adder using decoder? We'll see here. I will take 3 inputs A, B, C, and how many outputs full adder will have? Yes.
2 outputs,
What are those?
sum and carry.
Sum and carry. Right. So 3 inputs means how many input combinations I will get?
8 input
8.
combinations.
Write down those. 1, 0, 0. This is important example. They will ask either full adder or full subtractor. I will be doing full adder. Next, we have to do the full subtractor. Right. This is very simple way to implement it. Okay. These are the input. Now, can you tell me the output? What is the output for the first input combinations? 0, 0, 0. What you are going to get?
0 0.
Sum is 0, carry is 0.
Sum is 0 and carry is 0. Very good. Next.
Sum is 1, carry is 0.
Sum is 1, carry 0. Next.
Sum is 1, carry 0.
Sum 1, carry 0. Next.
Sum 0, carry 1.
Carry 1.
Sum 0, carry 1. Next.
Sum 1, carry 0.
Carry 0. Next.
Sum 0, carry 1.
Carry 1. Next.
Sum 0, carry 1.
Sum 0, carry 1. And next, lastly,
Sum 0, carry 1.
1 carry 1.
sum 1, carry 1. I hope all of you know this truth table. Right? So, if you want to implement any function using decoder, what you need? You need the output expressions in SOP form, canonical SOP form. Write down those output equations in canonical SOP form. So, I will write sum equal to and carry equal to, sum equal to sigma m. Can you tell me? From this truth table, you have to write this. What is sum equal to? Sigma m. Which is this?
1, 2, 4, 7.
1, 2, 4, and 7. So, right. 1, 2, 4, 7. And carry? This
3,
is
5, 6, 7.
1, 2, 4, and 7. What is carry?
3, 5, 6, 7.
3,
3, 5, 6, 7.
3,
5, 6, 7.
3, 5, 6, 7. 3, 5, 6, 7. And once you got the expression, now it is similar to the previous problem which you have solved. Right? I have not given the expression explicitly. I told you have to design some combinational circuit, that is full ladder. So you have written the truth table of the full ladder. You got the expressions for sum and carry. What is the last step now? What is the last step? Yes? What is the last step? To implement this using decoder and OR gate. If it is active high decoder, compulsory you have to use OR gate. And if it is active low decoder, you have to use the NAND gate. So what I should show? Which decoder I should show here? Which I should show?
3:8.
3:8.
3:8 decoder. So how many inputs 3:8 decoder will have?
3 inputs, 8
3,
outputs.
that is A, B, C. And how many outputs it will have?
8 outputs.
0, 1, 2, 3, 4, 5, 6, 7. So you can write this 0, 1, 2, 3, 4, 5, 6, 7. Fine. 3 to 8 decoder you have now. Now I want to implement sum. What in terms I should get from this decoder? 1, 2, 4, 7. So what I need to do? What I need to do? 1, 2, 4, 7 I need to take. So what? Take 1, then 2, 1, 2, 4 and 7. And what I need to do? These 4 should be given to 1, 4 input. Which gate?
OR gate.
OR gate, and that will give you sum. Similarly, 3, 5, 6, 7. 3, 5, 6, 7. This should be given to one more OR gate, and you will get what? Yes. That is the designing of what? Full ladder using what? 3 to 8 decoder and the OR gate. 3 to 8 decoder and OR gate. I hope all of you understood this. Any doubts here? Right? Okay. Now I'll give the next example. All of you understood this, then we'll go ahead and implement it. Okay, you take down this as a homework. Just check the screen, whatever is there on the screen, you can copy down that. What is visible on the screen? Yes, someone can read it. Can someone read it? Are you able to see the screen or no?
Yes, sir.
What is
Yes,
the question there?
Show how using a 3:8 decoder and multi-input OR gates following
Following
Boolean
Boolean expression can be realized simultaneously. What is the first equation they have given?
F1 of ABC is sigma m 046.
046. Then F2 of A comma B comma C is sigma m 0,5 and
F3
1
is
comma 2 comma 5 comma 7. Right? 1, 2, 3, 7. Sorry. So this is very simple now. You can implement it. You have to do it as a homework. So like this, you have to use 3 to 8 decoder. Show ABC as the inputs. You will get the 8 outputs. Take the corresponding term, give it to multi-input OR gate, and you will implement it. Like how we have done. 2 examples already we have done. Similarly, this is the third example which you can do it easily. Right? Is that clear?
yes,
Will
sir.
you be
Yes,
able
sir.
to do that?
Yes, sir.
Okay. You can do this also as a take next example. Implement following function using 3 to 8 decoder and NAND gates. And NAND gates. Implement following functions using 3 to 8 decoder and NAND gates. The first function is sigma m 0, 3, 5. F2 is 1, 4, and F3 is 2, 4, 5, 7. 2, 4, 5, 7. 2, 4, 5, 7. Okay. Okay, that also you need to do it as a homework. You take the next example now. The next example you can take, right? Implement full subtractor. Implement full subtractor using 3 to 8 decoder. Implement full subtractor using 3 to 8 decoder and NAND gates. 3 to 8 decoder and NAND gates. Okay, how you should do that? Yes, quickly, can we do it? All of you? Now, full subtractor means what change I should do here now? Yes. What is full subtractor? A combinational logic circuit which is used to subtract 3 single bit inputs is called as a full subtractor. So what are the inputs? Again, I can show 3 inputs, and what outputs I can show? Yes, you can write the outputs as what? Difference and what? Borrow. Like sum and carry, you need to write now difference and borrow. Okay, so I'll give only the truth table part, and the other thing you need to do it. What is the output for the first case? All of you, can you tell me? Yes?
0, 0.
Difference is 0, borrow is 0. Now for the second case, how you should do it? First you should do 0 minus 0 is 0. Then 0 minus 1. 0 minus 1, what you will get? Difference 1, borrow 1. Right? So simple thing you should remember, 0 minus 0 minus 0 is 0. Or you have to remember this, 0 minus 0 is 0, 1 minus 0 is 1, 1 minus 1 is 0, and 0 minus 1 is 1 with borrow 1. Right? This is called as difference, and this is called as borrow. These are the rules for subtraction you have to remember, and accordingly you can complete the table. Is that clear? 0 minus 0 minus 1 is 1, 1. Now what is 0 minus 1? 0 minus 1 is 1, 1 minus 0. Again 1, 1.
1, 1.
Then 0 minus 1 is what? 1, 1. 1, 1 minus 1 means
0, 1.
0,
1.
1. Is this clear? 0 minus 1 is 1, 1. From that, you have to take that 1 subtract again. So 1 minus 1 becomes 0, and that borrow remains as it is. Then difference is 1, borrow 0. 1 minus 0 minus 1 is 0, 0.
0,
1
0.
minus 1 is 0, 0.
0, 0. 1,
1
1.
minus 1 is 0, 0 minus 1 is 1, 1. Fine. Now write the difference. What is this? 1, 2, 4, 7. 1, 2, 4, 7. And then borrow is what? 1,
2, 3, 7.
3, 7. 1, 2, 3, 7. Right. Now, if they say like 3, like decoder and OR gate, you would have done the same. But what they have told now, you need to use what? Decoder and
Navigate.
decoder and what? What they have told? When they say decoder and NAND gate, you have to show output inverted here. Okay? output is inverted now. That's why they have asked you to use NAND gate. So take, what is that, 1, 2, 4, 7 now again. 1, 2, 4, 7. One, 2, 4, 7 should be taken and given to which gate now?
NAND gate.
NAND gate. You write this as difference. And then 1, 2, 3, 7 again you take 1, 2, 3, 7. You need to use another NAND gate and you need to write it as what?
Borrow.
Borrow. This is the difference between active high decoder and use of active low decoder. Right? 1, 2, 3, 7, 1, 2, 4, 7. Any doubts here? All of you understood this?
Yes, sir.
I want all, whether you have understood this or not. How this is very important part. Normally, you will expect a question on this implementation of Boolean expressions using decoder and OR gate or decoder and NAND gate. When they ask decoder and AND gate, decoder and OR gate, it is active high decoder. And when they say decoder and NAND gate, then you have to go for active low. And I have shown what is the difference between the representation of active high and active low decoders. So I hope it is clear. All of you understood it?
Yes, sir.
Any doubts in the decoder part? This is very important part. Again and again I am repeating. If you have any queries, you can ask me.